Okay, so we talked about singleton. Now we'll be talking about something from structural patterns. Okay, so remember, structural patterns is help how to assemble objects and classes that are larger structure while keeping the structure flexible and efficient. So creational patterns is all about creating mechanism, how we can create new instances, how we can create new objects in our application. But with structural patterns, what we'll do is we will see how we can assemble objects and classes into large structures while keeping the structure flexible and efficient. That means we'll be looking into like assembling, not creating, okay, object creation and assembling objects. So these are two different concepts. Let's see how the structural patterns gonna be useful in this AI. Okay, so let's see, we will be using something very easy in this structural patterns. Otherwise, sometimes some patterns are really complex in nature. We'll use something like decorator. Okay, so that's easy for understanding. Okay, so we also known this as the wrapper pattern. Okay, we use this to hide the complexity and make it work. Okay, so as we discussed yesterday, for a design pattern, in order to work, there is like four key features that we need to talk, or there are four key features that help us to classify the design pattern. So let's first talk about the intent of this design pattern. Okay, so decorator is a structural design pattern that lets you to attach new behaviors to the object by placing these objects inside special wrapper objects that contain the behaviors. So you guys know the usage, or if you guys have seen what do we call these things, are Russian dolls, if I can remember. So if you take a Russian doll, what will happen is there is the smallest doll that available, and inside that doll you will find so we have the smallest one, then again we wrap it around another doll, and we wrapped this one in another larger doll, and list goes on. So when we got the latest one, so we have, when we remove the outermost doll, we get a smaller one. When we remove that, we got a slightly smaller one, then until we get the smallest doll that has been wrapped. Okay, so as this pattern behaves, like we attach new behaviors to the object by placing object inside a special wrapper. So we add the intended behavior, we add the extension of the behavior by simply wrapping it in another layer of code. Okay, so we have the original one, we wrap that object in another object by simply on top of it. Okay, let's see how we can do, and what is the problem that we're going to be solving. Okay, so imagine that you are working on a notification library which lets other programs notify their users about important events. So that is the problem definition. This is a situation where decorator patterns shine. So let's imagine a situation, a notification library. Let's other programs notify users about the important events. So we are working on a library in here. Okay, notification library. Have the concept and have the idea around where it is really going to be working. So we are trying to work with a library that's going to send a notification to other people. The initial version of the library was based on the notifier. Assume that initially the library was built using a class called notifier. Class that had only few fields, a constructor and a single send method. So a really simple class. Okay, so it has few fields. We do not want to discuss each and every one, but let's assume that there are a few fields and there is a constructor and there is this send method. Okay, the method could accept a message argument from a client and send the message to a list of emails that were passed to the notifier via the constructor. Okay, so we can imagine the class itself. The method is accepting a message and a list of emails that we need to send the message. So there are two things the message constructor is asking. First one is, what is the message that you want to send and to whom you want to send. So these are the simple constructor that we need to supply for the notifier class. Okay, so the notifier class is pretty simple. It has a bunch of fields, it has a constructor, and it has a send method. The constructor is asking for what the message that we want to send and to whom we should send. That's it. Okay, a third-party app which act as a client was supposed to create and configure notifier object once and then use it each time something important happened. So this is the use case. A third-party app which acted as a client was supposed to create and configure notifier object once. Okay, remember these keywords, and then use it each time something important happened. So what we need to have to do is we have a client that is going to take this notifier class. Okay, we have the notifier class, notification library, which is available, and we will use the newly created notifier object, and the message itself will use the notifier.send to send the notification. Okay, remember this is the use case of this class. In this scenario, we use the application class. So application class has a private notifier, and this notifier will have the method called notifier.send, because notifier class has this public method send and whatever the message that we want to send, and we can send it back. At the same point, you realize that use of this library expect more than just email notification. Okay, so we are building a full-fledged notification library. Okay, so we are initially, they have supported sending by email. Okay, but the users of the library, okay, this library, and they want to send the notification, not just email, but now we want to send as SMS. Okay, so email sending and SMS sending are these are two different technologies, two different methodologies, two different protocols to handle. So the implementation, for these things will be different. Okay, many of them would like to receive SMS about critical issues. Other would like to be notified on Facebook. Of course, the corporate uses like a Slack notification. So now it is diversifying even further. So some people like to have received these things as SMS. Some people like, okay, rather than sending SMS notification, they might be interacting with Facebook more often. So they will be, they would like to receive the notification via Facebook, and someone who's using Slack, they would like to receive the notification via Slack. But remember, our core capabilities of the notifier class is just sending via email. Okay, now we want to diversify, we want to change this behavior to other notifications. So how we going to incorporate those things? Let's see. How hard it be there, right? It shouldn't be that hard. You just extend the notifier class and put the additional notification method into new subclasses. Now the client was supposed to initialize the desired notification class used for all the notifications. So it from your head, it will be something easy, right? Why? So we know the basic concept behind object-oriented programming. So in this scenario, we would just extend the notifier class. Okay, so we have the class notifier, and what will be have in here is rather than sending rather than using the email notifier, we will have subclasses that is spin out of notifier. We will have a subclass called SMS notifier, Facebook notifier, Slack notifier. Then we can implement the method via those subclasses, right? So that's going to be easy. Then the users might ask, but someone reasonably asked, why can't we use several notification types at once? If our house on fire, you would probably want to be informed through every channel. Yeah. So a valid request might be. So rather than having several different notification types, okay, we have several notification subtypes now, because notifier is the parent class, and SMS notifier, Facebook notifier, and Slack notifier would be subclasses. Okay, but imagine multi-channel notifier. So that means we want to get all the notification channels if some emergency thing happen, like if your house on fire. So each and every possible way we should be able to get these things, right? You should have an SMS notifier, Facebook notifier, Slack notifier, email, whatever the notification mechanism out there. If you can get all the notifications, that would be the best and ideal one, right? That is like the use case in one particular scenario. Yeah. So yeah, that's a valid approach, right? That is like valid something like that. So what we can do, you are trying to address this problem by creating special subclasses which combine several notifier methods within one class. However, you quickly become apparent this approach would be bloat code immersively, not only by the library code, but the client code as well. So we might do, since we have subclasses, so we can have different combination of these combinations of these subclasses, right? So we have SMS plus Facebook notifier. Okay, that's combined the notifier with SMS and Facebook, Slack and SMS, all three together, Slack and Facebook. Likewise, we can have the different type of combinations in here, right? That is a valid, reasonable assumption that someone can come across. But we will soon regret this decision. Why? So now you guys can see that the SMS notifier that you see in here is somewhat part of this SMS plus Facebook notifier. So the part of SMS notifier is held in this class, this class, this class, except this one. Okay, so sending SMS notification, it will be embedded in each and every of these class. All right, same goes to the Slack notifier, same goes to the Facebook notifiers. So the implementation would be scattered around the classes. Okay, and imagine another notifier method comes into play. We get let's say we want WhatsApp notifier to be added to this. So imagine the complexity grows between these application and between these classes. How are we going to handle these kind of things? So the combination grows, when combinations grows, and the places where interact with these things going to be grow. So it's going to be chaotic. So we should have a better way of organizing and organizing these kind of things. Okay, so these are the valid use cases. Do not get into the idea of, okay, this is gonna be only for notifiers. No, just take the problem itself. Okay, so the bloat number of subclasses and implementations on each of these things. So take that as the problem, take those things as the problem definition, not do not get classified to notifications only. This is one problem use case. Something similar might come when you work with these things. So so yeah, we should find a better way to get these done. Let's see about the solution that we can get. So you guys can see that again with the design pattern. These are not algorithmic questions, right? It is not an algorithmic problem. This is what we call a problem in general. Okay, so if it is an algorithm, yes, you guys get set of instruction. Let's use this, and it will be resolved. But in design patterns, as I told last time, it is not the case of resolving a problem, but itself resolving a problem definition that is implemented in several languages, several methods that is available. Okay, so what is the solution that we can take on this? What is the solution that we will be using to that we'll be using this to overcome? So extending a class, the first thing that comes to your mind when you need an alt object behavior. However, inheritance has several serial keycats that you need to be aware of. Yes, so first thing that you would think in a scenario like this is extending a class, right? We normally, when we want to, the inheritance itself, okay, inheritance itself is the mechanism that gives us to go beyond what is defined in the application. We will be having more behaviors, more behaviors on the base class, and we'll have more adding, and we will add more to the existing class. That is what we're gonna do, but it is not the optimal solution every time that we know. Yes, or in OP subjects or OP concepts, we learn about these things, but they are coming with some cost as well. See, let's see what are the cost of object-oriented inheritance is. Inheriting the statics, you won't alter the behavior of existing object at runtime. You can only replace the whole object with another that is created from a different subclass. So by inheriting something that you will be doing is, you can't alter the behavior at the runtime. So you can't change the behavior at runtime. What you can do is, you can only replace the whole object with another one that is created from different subclass. So you guys can see that when we are implementing, when we are inheriting inheriting and inheriting a subclass, what will happen is it will have the same basic methods. If you guys can remember, in the notifier class in here, it has the same message method. Okay, by inheriting this, what we can do is we can override this send behavior. Remember, basic object-oriented programming, it allows us to override this send method. Since this is a public one, we can override within our application. So we will override, and we won't be able to add anything from inheritance. We can add more things, but it's not going to be the same like what we have done in the parent class. So subclass can have just one parent class. In most languages, inheritance does not act lets a class inheritance behavior of multiple class at the same time. Yes, this is something most of the modern programming languages have as a problem. So you can't inherit from multiple parent classes. That is not allowed, especially programming languages like TypeScript, Java. Those programming language does not allow us to inherit from multiple classes. It's only allowed to inherit from one single parent class. So that is a limitation of most of the languages that we have. So it's going to be problematic when we want to combine the behaviors in some occasions. For example, let's say we have SMS notifier. Okay, then what we need to do is if we want to have the Facebook notifier as well, so we can't just simply have inherit the SMS notifier and the Facebook notifier. The reason is behind that SMS notifier has the send method, Facebook notifier has the send method. So if we have these send methods, if we take SMS notifier and try to extend this Facebook notifier, then we are overriding the SMS notifier send notification method. So we only have then the Facebook notifier. Okay, so if you try to have Facebook notifier and extend it by the Slack notifier right over here, what will happen is it will override the send method from Slack notifiers method, because these things are inheriting from the same notifier method. It will override. Then if we try to inherit the Slack notifier from the Facebook notifier, then the Facebook notifier will go away, Slack notifier will come from. Same goes to the other ways around. So that is going to be a problem. That's why we need to have these kind of classes, SMS plus Facebook notifiers. Okay, so this subclass will have send from Facebook and send notifier from SMS. So that's going to be a completely different new class, which will have send SMS, send notification, but also the send methods. So this is going to be a problematic when we go through the inheritance. There is a problem that we get through inheritance. So what are the things that we can overcome? Okay, one way of overcome these clear cut is we are using aggregation or composition. So these are two ways that we can use to overcome this. The aggregation object contains B can live without A. That is the definition of aggregation. Composition, we call it object A consists of object B. A manages life cycle of B. B cannot live without A. So these are like the other alternatives that we can come with overcoming to these problems. So these are two different concepts. Okay, to these two different concepts. It is alternative to inheritance. So these are like what we call is a way of inheritance, like not direct inheritance. Like if you guys have seen, we can directly inherit things by using extends keyword, but without inheriting directly, we would use an aggregation. Okay, so in aggregation, what we do is we have object A contains object B. That means think about, do not think in terms of parent and child. Think parent, not in terms of parent and child, but A and B, two different objects. So A contains object of B. B cannot live without A. That means we have two notifiers that we need to do, and we can take one notifier. We do not extend or anything like that. What we do is we have A, within A we have B. So in terms of our example with the notifier, let's assume that we have the SMS notifier and we have Facebook notifier. So we have SMS notifier. Within that, we can have the Facebook notifier. Okay, so we have one and another one, but it is aggregated within that. So in this aggregation, one thing will you have to remember, that the second one, the one with living inside the other one, can't live without the original objects. That means from our context, the Facebook notifier won't be able to live without the SMS notifier. That is the basic definition of aggregation. And remember, it is not inheriting anything from a SMS notifier to the Facebook notifier. That is not inheritance. That is what we call an aggregation. We have a similar concept called composition. Okay, object A consists of objects of B. Okay, and B manages life cycle of B. B can't live without A. So so in this scenario, we have object A and we have object B. A is responsible for managing life cycle of B. That means the creation and deletion or anything that happens to B is managed by A. And without A, B cannot live because it's managing all those things. So we will see the composition and aggregation in more detail. Right now, have the basic idea of what is object aggregation, what is object composition. These are two alternatives to inheritance, which we will use in this scenario. So both of these alternatives are almost the same way. One object has a reference to another delegate some work. Okay, the main key in here, object has. Okay, when we are talking about inheritance, we use the term is. Okay, is. So we can say in this scenario, SMS notifier is a notifier. Since we are inheriting from the notifier class, we use the term is to identify this SMS notifier. So we can say SMS notifier is a notifier. So when we are using the keyword is, that implies that this is an inheritance that we are talking about. But when we talked about object by referring has, okay, the keyword is has. So we are talking about in here either a aggregation or a composition. Okay, so we are not inheriting something. The keyword is not used. So we have the we have the terminology has. Okay, has a reference. So when we talk regarding objects, and we simply say object A has a reference. That means, okay, there is no inheritance. We are going to be talking about an aggregation or a composition in here. Okay, remember those words. Those are really, really important in the context of understanding these things. Okay. So where is inheritance itself is, okay, this is the keyword that you want to have. Object itself is able to do the work. Inheriting behaviors is from its superclass. So remember, inheritance, object itself is able, and reference or aggregation we talk about has. Okay. All right. With the new approach, we can link a helper right around in here. Let's see what we are talking in here. With this new approach, you can easily substitute the link helper object with another, chaining the behavior of the container at runtime. So we will be chaining this behavior at runtime. Let's see how it goes. An object can use the behavior of various classes having reference to multiple objects and delegating them all kind of work. So at the runtime, we can have various classes in order to work with this. Okay, let's see how it goes. So aggregation composition is the key principle behind many design patterns, including Decorator. On that note, let's return to the pattern of discussion. Okay, so remember, most of the time, most of the patterns that we are using nowadays, we use this aggregation or the composition to overcome the limitations between inheritance. Okay, so it will be easy to have more flexibility, or we can avoid such pitfalls of inheritance. I'm not saying that aggregation or composition is the superset or is the thing that we should always use. No, based on the use cases, based on the usages, it might be different. These things might be slightly different in use. So in inheritance, you guys can see we have a parent. Parent is deriving these two children. But on aggregation, we have a relationship to another. So we do not use the terms parent and child in here. We use the reference has a relationship. Okay, a service has a relationship with, sorry, the client has a relationship with the service. Okay, so this is what we call the aggregation pattern. So Wrapper is an alternative nickname for the Decorator pattern that's clearly express the main idea of the pattern. Okay, that's why we use the term Wrapper. Wrapper is an object that can be linked with some target object. Okay, the wrapper contains the same set of method as the target and the delegate, and it's all requests it receives. However, the wrapper may alter the results by doing something either before or processing. It passes the request to be target. So in here, so the Decorator pattern in here, we use the term wrapper all the time. So if you hear the term wrapper in programming language, that simply means we are doing some changes with the targeted object that might fulfill our need. Okay, so the target object in this scenario is going to be the most of the top on the root, and this targeted object will be changed, or this will be used in order to achieve our target, achieve our functionality. But these wrappers contain methods to delegate its requests it receives. So that means we are not directly talking to the target object. Okay, we do not have we are not directly communicating with that, but we have intermediate step. We have steps in the middle that will um, that will uh, that will say, okay, this is gonna be something something gonna be little bit different. Okay, so we do not have the direct access to the target, but we will have some intermediate methods to delegate that request. That means if there are any pre-processing, if there are post-processing, those things will happen, and we'll be able to use this. Okay. Got a question. Is aggregation or composition implements the class inside of another class? How we can implement the code with example? Yeah, so we will see these things in example right around once we complete the theory behind it. Let's see, this is in code, so you might get a better idea on that. Right now, just let's go with the theory, and at the end we will implement this, how we can use aggregation, how we can do the wrapping and everything. Okay. Okay, when does a simple wrapper becomes a real decorator? As it implements a wrapper, implement the same interface as the wrapped object. That's why the client perspective, the objects are identical. Make the wrappers reference, accept any object as follow that interface. This will let you cover the object in multiple wrappers, adding the combination behavior of all wrappers to it. So when we do a simple wrapping, okay, then we will see different implementation of the same interface. So we'll be able to interact with multiple interface, multiple objects. Okay, so so the simple object will have multiple wrappers, adding the combination behavior of the wrappers to it. Okay, so let's see our example class and try to get an idea around this scenario. Okay, give me a minute, guys. Okay, sorry about that. So let's take our example, notification example, and see how we can overcome the problem that we had using some um, code itself. Okay, let's use the diagram first, then we will try to implement this. In our notification example, let's leave the simple email notification behavior inside the notify class, but it turns all other notification method into decorators. Okay, so when we are um, when we are talking about the notification class, we have the initial way, or the initial behavior of the email notification class is just to send email notification, right? So we will leave that the simple notification with the notify class. That means if we by default send a notification, that's gonna be what we call it's going to be email notification, but all the other methods into a decorator. Okay, so let's look at the example in here. Let's look at the class diagram in here. So you guys can see we have the notifier class and we have the public send method, and we will accept a message to be sent. And the base decorator class, what we will have a wrapper. Okay, we called it wrappy in this scenario, and it's gonna be a private what we call a private variable, and the type will be notifier. Okay, so it has the constructor, the base decorator. You guys can see the name, the same name that we have used in here. So we know this is the constructor, and it is accepting a notifier that we will be setting out in here. And when we want to send something, when we want to send some notification, we'll just use the wrapper.send, because we have the base class of the wrapper to send the notification. And when we call the public method send, it will use the wrapper.send. So the wrapper is a type of notifier, and notifier sent message will be used to send by default. Okay, this is the default implementation. But in other terms, in other sections, we have the other decorators. Okay, so SMS is going to be a separate decorator. Facebook, Slack in this scenario is going to be a separate decorator. So they will have the same implementation. You guys can see they will have the send method by each. Okay, various notification become decorators. And sorry, once you want to send something, it will call its super send method. That means it's going to be calling its parent decorator, and it has this method called send SMS. Okay, the send SMS would be the decorator for this one. We'll see how the send Facebook and Slack is going to be there. So for just to get an idea, we restructure our code into something like this, and we will see these things in action. So it will make more sense rather than the diagram itself. Okay, the client code would need to wrap the basic notifier object into set of decorators that matches the client preference. Resulting object will be structured as a stack. Okay, so we will be using a stack in order to do this. So say for example, we have a new notifier called stack. If it is Facebook enabled, okay, if the Facebook is enabled for some reason, we will use the stack to a new Facebook decorator. If Slack is enabled, we will have the stack for a new Slack decorator. Okay, so by implementing this, you guys can see the decorator itself take the notifier itself. So we will have the notifier implementation on each time, and the app itself will set the notifier as the stack that we have created. Okay, so when we want to use the notifier method, and we want to send notification, and we will be sending notification something like notifier.send. That is the default method, and this is going to be in, let's say for alert. Okay, so it will configure stacks like email. Then we can use Facebook, we can use Slack. So all these things are stacked together, and then once we have enabled, if we were to enable Facebook and Slack on Slack at the same time, then the email notification, Slack, and SMS notification will be gone. Okay, if you disable one of these things, if you do not want to send the message from Facebook itself, then what will happen? Those things will be defaultly disable. That means we are sending only whatever in this stack implementation. So we'll see this in action, so you will get a better idea. The last decorator in the stack would be the object that client actually works with. Since all decorator implement the same interface as the basic notifier, the rest of client code won't care whether it works with the pure notifier objects or the decorated one. That means since we are at the end when the application works, we will be working with this stack notifier. So whatever the notification message we send, we don't care what is the implemented notifier is. As long as this stack is available for this notifier, we can send the notification on the proposed decorators. Okay, we have Facebook decorator, we have stack decorators. We can send either one of these things. So we don't need to worry about the client or its implementation. It will just work as we have configured. We would apply the same approach to other behaviors such as formatting, and message composing the recipient list. The client can decorate object in the custom decorator as long as they follow the same interface for the others. So we can change the behavior for other methods as well. So we'll see this thing in code example. Then we will see it in real world. Okay, so think. So we think this is in real world anatomy. Like if you are a cold person, and if you wear a jacket over it, you will be proof from cold, right? And if you have a raincoat over it, what will happen? You will be covered from what we call rain as well. Okay, so this is like adding some more functionality on top, and we will move forward. That we will be superior when its implementation goes by. So wearing cloth is example of using decorators. When you are cold, you wrap yourself in a sweater. That is true. If you still cold with a sweater, you can wear a jacket on top of it. Okay, if you feel you want more protection from the cold, you can wear a jacket over it. If it is raining, you can put a raincoat, right? All of these garments extend your basic behavior, but aren't part of you. It is not part of you. You can easily take off any piece of clothing where you don't need it. Okay, so if you don't need any of the parts that you find that is unnecessary, you can remove those things. As you might have seen in this stack implementation, that is what we are doing. If you do not need Facebook notification enabled, you just remove it. So you will have this Slack decorator working with that. Same analogy goes in here. If you are in rain and you say for some instance you do not need the cold protection, you can remove the sweater, but you can keep the raincoat on. So you will be protected from rain, but not from the cold. Okay, based on what your preference is, you can remove anything, and it will protect based on the occasion. Okay, so let's see how the structure of this will work. Okay, so this is like the implementation of the decorator pattern. So this is going to be a little bit complicated. It will add more complexity to what we are doing, but let's try to decode everything one by one. Okay, so it's not going to be using the same notifier pattern. The notifier examples that we have written, but we will use something else. Since we get the idea from the notifier, we will apply that in different place. Okay. So the structure in here goes like this. So we have the client in here, and the client, the first thing that we will need is an interface called the component. The client is where we will interact. We will have a component which will have the method, public method called execute. And we have the concrete component. You guys know the abstract and concrete implementations. So the concrete component is an implementation of this interface. So it will have the execute method. And we will have the base decorator out of this. That's going to be a wrapper. And we have the base component out of it, and the base decorator, that is going to be the same thing, and it's going to have the component interface, and we have the execute method as the interface suggested. And from this, we will have a concrete decorator. This is the first decorator of this implementation. So it is like the notifier. So it will have the execute method as the base suggests. And when we are calling, it will call the super execute method. And if you want, you can have the extra method to extravagate the application. And this is going to be the decorator itself, the decorators in use case. So we will create a concrete component, and we will create a concrete component 1, which is going to be using this component A. And we will have a third one that will use the concrete decorator with 2. Okay. And we will follow the implementation of B. And once we hit execute, it will call the decorators in this order, and the execution will happen. So let's see this in action. So these are the steps that we're going to be taking along, how we can have the decorator pattern. Component declared in a common interface for both wrapper and wrapper objects. So we have a common interface. Concrete component class of being wrapped define basic behavior such can be altered by the decorators, the base decorator, concrete decorators, and the client. So let's take this code into action. So the easiest way, as we discussed earlier, we use the pseudocode. So the pseudocode is guiding us how we can do the decorator pattern, and we will implement this by any programming language that we are familiar with. So we get the pattern into our understanding. Okay. So let's clear our mind. We learned few things, but let's try to implement the pseudocode and try to get the implementation working on. So by implementing this code, we will get a better idea of the decorator itself. Okay. So in this example, the decorator pattern lets you to compose and encrypt sensitive data independently from the code that actually use this data. Okay, so we will be developing compress and encrypt sensitive data independently from the code. So that means we are going to be using a simple encryption mechanism. And the beauty of this is it is independent from the code. It actually uses this data. That means the data source can be varied. The data source might be not from something like user input, file input, whatever the data input, it will be independent from that. Okay, so we can understand there is a client and there is the data source. So data source is where the data is coming from, and we have the write data and we have the read data. So we have two decorators that will be implementing this data source. Okay, as I mentioned earlier, the data source is going to be the base, and the decorators will have different implementation on those things. Okay, so we have file data source. That means we will be taking data from a file, and we have data source decorator that will be decorating on top of this data source. So we have the encryption decorator and we have the compression decorator. That means each of these decorators, the data source decorators, will have different functionalities on each of these things. Okay, so these things add more functionality. So we'll see this in action, how we can implement this. Okay, the application wrap data source object with pair of decorators. Both wrappers change the way data is written and read from the disk. So we have data. Okay, we have data that is coming to our application. Both wrappers change the way data is written and read from the disk. So there are two operations happening in here. First one is the encryption. The other one is the compression. Okay, so rather than implementing these things in subclasses, we will use the decorator. So one decorator will do the encryption, the other decorator will do the compression. But in order to do that, in order to work with these things, anyhow, we need to read data and we need to write data. Okay, so the compression, what it does is we read the data and we compress and we write that data. In encryption, what we do is we read the data and we do the encryption and we do write the data. So you guys can see the operation might be different. Okay, so encryption and compression, those are like two different things, but what they are doing, what the base class is supposed to do is the same functionality, reading and writing. So this is going to be a decorator. Why? Because the functionality they perform, the functionalities they are interested in is two different things. So when we are using the data source decorator, we can have okay, if encryption is enabled, we can have the encryption decorator within our class. If compression is available, we can have the compression decorator in the class. If both of these things are available, when we are reading and writing data, based on the enabled decorators, it's gonna encrypt or it can compress or it can do the both. Okay, so what we have in here is the data source decorator. So by enabling these decorators, by enabling these things within our application, the things that we do, the things that we are supposed to do is going to be different. Okay, so these decorators will act as extension to our data source. Okay, so it is like adding few features while we do the things. So let's see this in action. So let's go the description one more time to make it clear. So the application wraps the data source object pair of decorators. Both wrappers change the way the data is written and read from the disk. Just before the data is written to disk, the decorator encrypts and compresses it. The original class writes the encrypted and protected data, the file, without knowing about the changes. Okay, so the original class write the encrypted and protected data file without knowing any about the changes. Right after the data is read from the disk, it goes through the same decorators which compress and decode it. Okay, so this is like the decorator availability. Based on these things, we can change the manipulate how the data source is working. Okay. Okay, let's see. The decorator and the source class implemented the same interface. Okay, you guys can see the decorators and the data source. These are the two decorators that we have. And this is the data source decorator. The decorators and the data source class implement the same interface, which make them all interchangeable in client code. That means we can change the decorator as we like. So let's assume the data source is an interface. So remember, we are not using the word has, we are using the word is. Okay, remember these things have very different different meaning. So we will create an interface which will be a data source. So there will be two methods within this interface: write and read. So write data will accept extra argument called data, because we need to know what are the data that we're going to write. So we will have a concrete implementation, because this is an interface. By implementing this interface, we will have what we call a file data source. Okay, this is going to be a data source type of file. So in the constructor, we need to give file name, because since this is a file-based decorator, file data source, we need to know what is the file name that we're going to be using. And since we are implementing the data source, so we need to implement this write data and the read data method. Okay. And again, we will come to the base decorator. This is going to be the base decorator that we are going to be using. So we will have a data source like what we have seen in here. You guys can see the repi, and this is going to be called the data source decorator implementing the data source. So we will have the base type, the base data source. And while we are constructing the data source, we need to provide what is the data source that we're going to be using. So it's going to be a wrap. It will be sent to the wrappy class that we are using in here. So in here, it's going to be file data source, but we need to have the flexibility to incorporate anything. Okay, so it will have the write method, and we will use the wrapper, wrappy in this instance, wrappy.write data. So whatever the wrapper that we are putting in this data source will be used to write the data. And the same goes to read data. We use the wrapper and read data to read the data. So the data source decorator is going to change on what the data source that we are giving. Okay, so this is the decorator, this is the source. Based on the source, that we are giving, the wrapper will change its behavior. Okay, so we have the two other data source, two other decorators: encryption decorator and the compression decorator. So what it will do is, we will not go into detail of the implementation, but when we call the write data, first encrypt the pass data and pass the encrypted data to the wrapper, wrappers write data method. So first thing that we're going to do is that we will encrypt the data by using any algorithm or whatever things, and we will pass this encrypted data to wrappers write data. That means we encrypt it, then we call its wrappers write data. So remember the class definition that we are using in here. This is a class, and the encrypted decorator is extending the data source class. It is not implementing, it is extending. So the first thing that it does is do the encryption, and it is calling its parent super write method to do the actual writing to that. So the read goes the same way. First, get the data from wrappers, because we need to get the data source. Try to decrypt it if it is encrypted, and return the result. So same goes to the compression class. The compression class, it is doing the same thing. Okay, so the compression decorator, what it will do is compress the pass data. So whatever the data that is sent in here, it will compress. Then it will call its parents wrappers write method in order to make this happen. Same goes to the read. First read from the wrapper, then decompress it if it is compressed, and return the result. Okay, so this is going to be the application which you're going to be using. So we have two decorators. One decorator would encrypt, the other decorator would compress. Okay, so based on the use cases of these two, it will do the compression while we are writing the data. So let's see this in action. First, first that we will do is we will use the file data source, so because we need to create file data source, and we will pass the file name because it is required in here. If you guys can remember the file data source, when we are constructing, we need a file name, and we can say source write data. Okay, this is the write data, whatever the records that we want to save. If you want to send some information, some string, whatever the value, we can send that. And the next thing is we want to compress this while we are doing the file decorators. We need to compress this, so we will create a compression decorator, and we will use the same data source. So if you guys can remember the compression decorator, this is the compression decorator, and the compression decorator requires a data source. Why it is requiring a data source? Because the data source decorator, its parent class, is requesting a data source to be created. So the when we want to compress these things, we just call the new source, okay, new source, and we call the write data, and we will write this data. The target file has been written, the compressed data. Now the data source will be writing data with compression in mind. Okay, and the next thing that we do is we take the same source. Okay, we take the same source. Remember, we are using the same source in here. We take the same source and go through the encryption data source. So we use the encryption data source now, and we are wrapping that around this source. Okay, now what will happen? The encryption data source, it will take the data source and it will call the write data. But when we are providing the salary data, now it is gonna do the encryption, compression, then file data source. So that's gonna be the chain of command that it's gonna be using. Okay, so now when we want to work with this implementation, so it will first encrypt, because that is the first thing that salary record is going to do. Then it's going to compress, then it's going to write in the file. So that is the implementation. So you guys can see the first implementation, the base file source implementation, it is just going to write the file. It is just going to write the file. That is it. With the compression decorator, it will compress and write the files. With the encryption, decorator, so we incorporate this data source with the encryption. Now it will encrypt, then compress, then do the file data source. Let's see this in action. We will write the code example and we will see where this in action. Okay, so now you guys can see, rather than extending each one another, so we could have extended the compression, we could have extended data separator. No, we just use the plain old data source and we add the capabilities by simply providing this into the other decorator itself. So we are wrapping around one on another, so it will work as an extension to the existing capabilities. Okay, so this is like a client code and external data source. So this is something similar to that. So in this salary manager, this is the implementation of these things. So we have this application. So we have the data source, and we will use the salary manager to have this data source, and we can see how we can do the reverse, like load the data and the save the data. Okay, so the given data source, by implementing the data source, it will do the implementation as required. So file data source, if data is enabled, we will go through the encryption. If it is enabled by decryption, it will go to decryption. And we will have the source manager, and we can get the load. That means we are simply going the backward, like we have implement the write data. And in this scenario, we will be using the read data. Okay. So I know it's sometimes it is too much to take in. Let's see these in action in real life coding, so you guys have a better idea on what we are dealing with in here. Okay, let me open the application right now. The projects JS will be using this application. Okay. Let me share my VS Code. Okay. So I'll take a different directory, so it will be easy for me to work. I'll say decorator pattern. Okay, just to have everything in here. So first thing first, I can create everything in one single class, but I will use different classes as much as possible. Okay. So first thing that we need to create is the let's say data source .ts. So this is the data source, and let's see what we need to do first. Okay, so first we need to declare the interface, that what it is doing. Okay, so we can say interface data source. Okay, so this interface will declare this interface will declare what are the functionalities available, like what we have seen earlier on. Data source, I think S is capital, right? Yes, data source, S is capital. So there are two methods that is available. One is write data, the other one is read data. So we have write data, which will accept data as type of string. Let's assume that it is going to be simple string, and it will have read data that will just simply read the data, and the return type would be simply string. And when we are writing data, we will just say void for sure. If we want something else, we will use something else. Okay, data source is not used. So this is the basic interface. Okay, that is done. Then we will adapt a file data source. So we will be using a file data source to implement this data source. So we can have multiple data sources we like. It can be file, it can be database, whatever the data source, it's gonna do this exact thing. So we will create a class that's gonna be file data source. Okay, this is the data source that we need to implement the data source interface that we are having. Okay, so that is the definition. Now you guys can see, whenever we say okay, we are creating a new data source which will be a file based data source, so we have to implement the interface. That is the basic of it. So you guys can see when we are writing data, we will get some string, and when we are reading data, we will get we will have something to read. So what I will do is I will just have some dummy data in here, so we can use these things in action. So how I'm gonna do that? So I'm gonna do one thing in here. What I'll do is I will say console log, okay, rather than like doing the actual file-based writing. I will just log it to the console and I will say writing data to file name, writing data to whatever the file name that we have given. File name with string, whatever the string that we are supposed to give, that is going to be data. So I'm going to use in double quotation in here. Oops. With string data. Okay, I don't need, sorry. Need this in here. And do. Okay, so the file name that we need to have. So we have the constructor with the file name that we are intended to use. So I will use create a constructor in here, and it will ask for a file name that's going to be in type string. Since I need to use these in here, I will use the private keyword constructor private. I will use protected file name. Okay, this stuff file name. I can use private. Format the code. What I'm missing in here. Okay. So when I'm using the file decorator, it is asking for a file name. Okay, this is the file name that we're going to be writing, and we will write data. Okay, based on the information, I will just simply, this should be implemented writing file data to write in somewhere in our disk, but right now I'm gonna just log it out so we can see it in action. Nothing fancy is going to happen. We'll just say, okay, this information will be written to this file. That's it. Okay, whatever the data it is receiving, it will be shown in here. So next thing we need to do is we need to use the data source decorator. So we use the file data source. Now we need to use data source decorator, which implement the data source. Okay, so this is the base data source which we can be writing, and this is going to be the data source decorators that we are going to create with encryption and the one encryption and compression. So before we use the encryption or anything, we use data source decorator. This will be the plenty of decorators that we're going to be using. So we will have a class which called the data source decorator. This is going to be the base class. Okay, remember there's going to be a base class always. This is the base class. So it will be implementing the data source. Okay, that is one thing. And what is the implementation that we're going to do in here? We use the wrapper in here. Okay, so we have to use the protected wrapper in here. Protected wrapper, that is going to be a data source. So when we are calling the right data source, what we're going to be using is this dot wrappy dot write data. As remember, we have to write the data that we are getting from the parent itself. Okay, this is the parent. Sorry, this is the decorator that we have passed. Whatever the method the wrapper is using, we call that wrapper's write data method. Okay. And same goes to the read data. Rather than implementing its read data, we will use the read data from the wrapper itself. Remember, this is one very important thing. So the base data source, the base data source is going to be the wrapper that we give, and it should be constructed. So we can say private wrapper. So we do not need this in private wrapper. It is okay. So we will be, when we are creating a data source, we will provide a data source, whatever the data source that we like, and it's going to be called wrappy. So whenever the data source decorator is used, this is the base class, it's going to simply call the wrappers data source. That is the expected. So we have two decorators. One is the encryption one, the other one is the compression one. So let's create those classes. So the class is encryption decorator. And remember, this is going to be extending. Remember in here, extending. Extends. The base one is data source decorator. All right. And when we are extending the when we are extending this, you guys can see, did I use the correct word? Okay. Encryption decorator is never used, and we will create the other one as well first. And the second one is the compression decorator. Extends data source decorator. Okay, so we have two decorators. First one is doing the encryption. The second decorator would add compression to this. Okay, so either of these decorators will be based on the data source decorator. So when we are creating an encryption decorator and we are creating a compression decorator, those things gonna be in the base type of this data source decorator. Okay, so we can't create a data source decorator by simply having it. We need to provide a data source that is going to be this file data source that we're going to be using, and we are going one by one, and we are providing the read and write mechanism. So remember, when we are writing data, it's going to call the wrappers write data method, and when we are reading data, we will be reading the wrappers read data method. So we are extending the data source of encryption decorator, and when we are encrypting, the methods gonna be totally different. So when we are writing data, okay, first remember, when we write, we get the encrypted data and we write it. Okay, so what we'll do is we will just assume that we are encrypting. We are not doing any changes, like we are encrypting these things. For demonstration purposes, I will just modify this string to concatenate with the encapsulation or something like that. Okay, so I will have data equals, I will have something like this, encrypted data. Okay, so think that this is the encryption that we are doing. I just simply add encrypted before the data, and the next thing that we need to do is we need to call the super write data method with the data that we have encrypted. Okay, so when we are using the encryption decorator, it has the write data method, right? It will have the write data method. So when we call the write data with the encryption decorator, what it does is it will encrypt the data, and we will call the super write data. The super one is in here, the data source decorator. That means it will take whatever the value is now when we are passing anything for the encrypted data, it will encrypt, it will just add the encrypted key string in here, and it will have the new data, and it will call it super. The super one is in this scenario the data source decorator. The data source decorator will simply call the wrapper, whatever the wrapper that we got. The wrapper is going to be a data source, a file data source. The file data source, the write method is going to writing data to whatever the file name and whatever the string that we work with. Okay, so I'm gonna just go with the encryption for now, and we will sorry, the writing data section for now. Later on, if we have time, we will look into read implementation as well. So when we want to use the compression decorator, okay, this is adding what we call compression to our data source. Okay, whatever the string that we have, we're going to be compressing it. Okay, we are not going to do the actual compression, but when we are writing data, what we'll do is we will have not encrypted, we will say compressed data. Okay, so I'll just amend the compressed in front of the data, and we will write it. We will call the super write in the sense the data source writer, and the data source writer have the wrapper, which is going to be this wrapper, and it is going to write the file. So this is the implementation for the actually one implementation, the write data method. Right now what we are having. Okay, and let's see how we can create this in action and see whether this is working. Okay, so first thing first that we need to do is we need to create this class in order to work. Okay, so we have the data source and everything, and we will run this class. Let me check where I have created this. I have created in the API section, and I can just simply call this call one of these function in a method. So I will create a function where I can execute. I will call this function like execute file decorator. Okay, this is the function that I'm going to execute all of these things in action. Okay, so first thing first, we need a file data source. Okay, we will be writing this thing to a file, right? So we need a file data source instance. So I will create a file data source instance. Const file data source. Okay, to create a file data source, I have to use the file data source. It is requesting a name. I will use the name, let's say Kara, no, super secret.txt. So I am creating a file data source, and it is called super secret. Okay, now I have the instance for file data source, and what I can say, okay, when I'm using file data source, write this data. What I'm going to write this data, once we can say meet me at 1 p.m. Okay, so this is the super secret file that we are using. Okay, so the file data source, if I use something like this, if I say file data source write data, then what we'll do, it's gonna do is it's gonna console log write data, the file name that I have put, and the data that I have put in here. So let's test that out first. So this is the base file writing process. That means if none of the wrappers, none of the decorators are enabled, what this will do, it will write meet me at 1 p.m. Meet me at 1 p.m. to the super secret txt file. Okay, so let's see this in action. First I need to run this. Give me a second. Okay, let me open the terminal in here so that we can see everywhere. And let's do so /API. Okay, I need the database and everything. I'll just open the database in another terminal. Do I have Docker? Should I would say compose file apps Docker compose apps. So you don't need to have the application running and all. You can have like TypeScript compiler to compile these things. Since I have done this in my web application, that's why the hustle. Otherwise, you don't need to have anything like this. You can just call this function. So in the main.ts, I will call this function in order to work. This is not needed. As long as you can run this code, that is fine. So I'm going to clear this. Try to run this one more time. Okay, so there are like logs enabled with the Nest.js application. Let me check whether I can stop the bootstrap. Okay, so I stop the bootstrap, so it will just show whatever the things that I am showing here. So you guys can see when I run this application, write data to super secret txt with string meet me at 1 p.m. Okay, let me put this file executor, this thing in quotation so it's easy to read. Okay, so it is showing me write data to super secret txt with string meet me at 1 p.m. Since I have not I have not used any wrapper, it's gonna basically the data source, the file data source. Sorry, it's gonna do nothing but just write this text to this file. Okay, that is what it is showing. Let me put the file name in here. That's fine. Fancy stuff. Write data to this and with this information. Okay, now for extending, for giving more flexibility, or to give more extension, we're gonna wrap these things in another data source. So we have two different decorators. We have the encryption decorator, and we will use the encryption decorator to give the implementation few more notches. Okay, so we will have const encrypted data source, and we can say new encrypted decorator. So the encrypted decorator is asking for a data source. So do we have a data source such? Yes, we have the file data source. So we can pass along that. So now when we use encrypted data source, what will happen? It will do something encrypted data source, and if I say write data, I will pass the same information in here and see what will happen. Okay, let's me save that. Now you guys can see I am calling the file data source one as well as the encrypted one. Okay, let me remove the file data source for now. And if I hit save, so now you guys can see write data to super txt file with string. Now it is not just doing uh, default file writing, it is calling encrypted because we are encrypted meet me at 1 p.m. So since we have added the encryption decorator to this file data source, now the default text that we are writing has become encrypted as well. So we have given extra capabilities to this file data source. Earlier, it was just plain writing, but since we are using the encrypted decorator, it is writing data with encryption in hand. So say for instance, I want to do const compress data source. Okay, new compressed decorator. It's also asking for a data source. Okay, so I will give first with I will first give the file data source. Okay, rather than I'm giving encrypted one, I will give file data source, and I will write the same thing, compress data source and write data. I'll give the same message to this one. Same message in here. Now you guys can see it is gonna be compress meet me at 1 p.m. Okay, so what it's gonna do, the data source I have, rather than using the encrypted one, I don't need encryption, I just need compression. So I have extend the capabilities of file data source to given by the compressed decorator, and it works as the file data source that I have put in here. So the compressed data source will write anything that we have put into compressed one. So we will now, the beauty comes, multiple decorators. If we have multiple decorators, what should happen? So so we have the file data source in here. The file data source is provided to the encrypted data source, and the encrypted data source I will provide to the compression data source. So now you guys see it. It is not just one decorator. It will have two decorators. First one is being the encrypted. The second one is the compression. But since we are calling the compression, since we are calling the write data on compression, first it will compress, then it will encrypt, then it will write. Let's see the things in action. Now you guys can see write data. Yes, first you guys see it is compressed. The first one we have passed is in compressed. Now the compressed meet me at, then feed it to the encrypted. Now it is encrypted, and it will be written to the super secret txt file. Okay, rather than we do one operation, the decorator will do two things, the encrypted and the compression, by the given order. Say for instance, I want to have the other way around. First we need to encrypt, then we need to compress. Then all I have to do is I need to change the decorator that I am using, the order. Only thing that I need to change the order. Okay, so first thing I need to do the compression. Okay, and this will be the file data source. That means compression decorator will have the file data source. The compression decorator will be provided to the encryption. Then the encryption data source will write the data. Now the order change. First we do the encryption, then we do the compression, then we will write to the file data source. Okay, now see this in action. Yes, you guys can see, write in data. First, we encrypt the data, meet me at 1 p.m. Then we are compressing the data as we like. So you guys can see the data source that we are reading in here is gonna change the order that we apply. Okay, so in here, what we can do is we can do something even crazier. So we have different instances of these things. Okay, we have the compression data source, encryption data source. So other than if it will be easy if we have just data source in here. We don't need const in here, but we have to use let in here. All right. Okay, that's saying that we have not used this. Rather than compressed data source, I will use the file one. So I will use file data source in here and file data source right in here as well. Type file name is property file name is same. I'm sorry, I think I file data source. One thing I think I implement data source. Yeah, there you go. So now you guys can see we have the plain old file data source. Now we add layers on top of it. Okay, the file data source is here. Now first we add the compressor decorator, which for the same file data source. Then we have encryption data source, the encryption data decorator. Then it will be encrypted. When at the end, when we call the write data, okay, when we call the write data, since it is first encrypted, it will be encrypted. Then it is second, it will be compressed, and it will work. Now you guys can see. Say for instance, I do not need encryption on my application. I'll just simply remove that. Now I only get compression. And if I don't need either compression or the encryption, I just remove that, and I will get the plain old one. And if I want to enable anything encryption, then here you go. Okay, so based on an if condition, I can simply say when we are executing, I need encryption, or I just need encryption, or I can just need the compression. All I have to do is have a if condition deciding what is needed, what is not needed. Then based on that, I can have the application to be sent out. Say for example, in here, let me say compress. Okay, compress. It's going to be a Boolean. Encrypt. It's going to be a Boolean. Okay, by default, I will assign these things as false. Okay, I don't need the type definition since I'm using true and false. So I can say if encrypt, then what I'll do is I will add file data encryption in here. If compress, then what I'll do is I will add file data force compression. Let me format the code so we can see clearly. So say for an example, in here, if I want the compress, by default it is false. You can see here, by default encrypt is also false. But since I have not enabled either one of them, so it will be meet me at 1. This is just super simple. But if I say, okay, I need first one, the compressed one to be true and not the compressed to be true and encryption to be false. Okay, now what will happen? Yes, it will be compressed and it will show in here. And if I make both of them true, then I'll get encrypted and compressed later on. Okay, so you guys can see the decorator, it's wrapping one on another based on our use case. We can say, okay, we will be enabling these things or not. Okay, that's going to be the simplest way of that we can do in here. So we can have more functionality to this class, but by simply adding more and more functionality. So we are wrapping around it based on the logics. Okay, so you guys can see the application works perfectly in terms of extension. And now you guys can see we do not have any inheritance all over the decorators. Okay, we have plenty of decorators. We just add those decorators one another, so it has a relationship between it. Okay, there is no inheritance going on with the file data source. It is not going to be there. It's going to simply add more and more functionality. Okay, so this is one of the examples that we have tried out. So from your guys' perspective, I expect to do the exercise on this one. Okay, take the notifier example. All right, do it today. Okay, don't let it skip your mind. Do it today. So take the notifier, take the concept. Okay, take the concept. Try to implement the notifiers, the same notifier, Facebook notifier, and the Slack notifier. Try to get the decorator implementation in here. You guys can see the even the base decorator and everything that we have done is going to be in here. So you guys can see the implementation. Just do the implementation and check whether the application will work. And if you have you can conditionally block like what I have done in here. If it is compressed, if it is encrypt, then everything will happen. But without these things, it will just do the same thing in your application. But remember, we are calling the super function in here encrypted, but do not get the message like Facebook and everything. You have to look at the logic from a perspective that is more understandable for you. Okay, this is a totally different scenario. The notification is going to be a totally different scenario. Okay, so do not try to implement the same way we did the file encryptor. It is something different, but the concept is the same. The concept is same. We need to add more features. We need to add more features to the existing wrapper. All you have to do is finding those decorators. Okay, do this thing and check whether this is working for you guys. You can use JavaScript, TypeScript, or whatever the framework of your choice or language of your choice. Just have the idea and work with that. Okay, do this one as an example. So you'll be believe me, you will be if you get this right, you don't need to memorize this to your examination. Believe me whatsoever. If you do this right, don't even think about looking at decorator pattern in your examinations. Okay, it will be there for you. Believe me, you have to do it yourself. Take the pseudocode and apply the same thing. Have a great plan first. Okay, like this. have the things that you need. All right, then have the plan, then imply those to the notification example, and it will just work. Okay, so I'm not going to go through the pros and cons at this point. You guys can look at these things by yourself, easily memorizable, and and you guys will get the idea pretty much soon. Okay, so it's have like a single responsibility in place. That means we are not we are not giving more extra burden to one single instance. It does what it does at best. Okay, so look at the relationship between the others. Other things, like we have the chain of responsibility, which is going to be a behavior pattern, which is same like the decorator pattern that we are having. Okay, so if you get decorator pattern, you will get chain of responsibility quite easily. So that is like things that you can get. Okay, have a look around all the other patterns as well. We will have a little bit of time to get into more. Okay, not this one, but catalog. Yeah. So we have talked one from the singleton, which is a creational pattern, and we looked at decorator, which is a structural pattern. You guys can see how we can assemble, right? We did not just create one, we give extra capabilities to these things. Okay, this is what all the structural patterns is doing about. And remember, having singleton, having decorator would not solve everything. Okay, there are several other structural patterns you guys can see. So decorator is one way of solving for particular problem. Okay, decorator, the other patterns, they don't have a similar conjunction with decorator, but they will have different way of solving a different problem. Okay, decorator will solve us the wrapping and extending the problem, so it is moreover helping us with compositing objects rather than inheriting those things. So decorator is one problem solver for one particular type. So we need to look into other ones like facade, flyweight. These are different ways of structurals, but for different contexts of problems. Okay, so we'll have a behavior pattern for next one. Obviously, the observable pattern is one I have in mind to work with. But if you're curious enough, go through each and every one. Believe me, it will save a lot of your programming time if you know these things. When you go to the industry, okay, believe me, like by learning these patterns, you'll get more into the design pattern. Yes, you will learn a way of thinking. Okay, Um, way of thinking to the application. Okay, and another thing that you will find that it gives us neat tricks into the programming language and a different thinking pattern for us. Okay, so it is like mathematics what we do in our classrooms. So more problems you solve, you can you have the practice by solving something similar. Okay, so you don't need to know the if you find something unknown, you might get an inspiration from what you have learned so far. So that is the theory behind of all these things. So make sure you guys learn these things in a way that these patterns will give you some insight of the programming language as well as a new way of thinking. Okay. All right. Any questions up until this, guys? Okay. Let me stop recording.